Yeah, so welcome my viewers on today's lesson. So today we are going to cover a question in Form 3. The topic is sequences and series. That is in Form 3. Sequences and series. There's a question on KCSE 2021. KCSE 2021. And that was on sequences and series. And the question is here on our board. So the first term of a geometric progression is 2. The common ratio of the geometric progression GP is also 2. The product of the last two terms of the GP is 512. So determine the number of terms in the GP. Determine the number of terms in the GP. Determine the number of terms in the GP. So this kind of question that's tested here, it is testing two things. One, it is testing if the student knows how to find the nth term of a GP. The nth term of a GP, it has a concept of indices in Form 2. A concept of indices in Form 2. So the rows of indices on multiplication is also tested in this question. So let's see how the examiner was testing this question. Now, so the first term of a geometric progression is 2. The first term. The first term is always given by letter A. The first term. And then the common ratio is given by letter R. So R is also 2. R is 2. So therefore, so when the examiner is talking of the product of the last two terms of the GP is 512. Examiner wants to see what's the formula of finding the nth term. Nth term of GP. The nth term of GP is always given by AR to power n minus 1. So the nth term, which in this case the last term, and the last term. So when the examiner is talking of the product of the last two terms, we already have the last term, AR to power n minus 1. That's the last term. The second last now, because we are talking of the product of the last two terms, second last term will be AR to power n minus 2. Because there's the last term, AR to power n minus 1. So therefore, second last will be AR to power n minus 2. That's what the examiner is testing. So that's the last term is AR to power n minus 1, and the second last is AR to power n minus 2. Therefore, get to the product of the last term, the last two terms. AR to power n minus 1 times AR to power n minus 2 is equals to 512. Is equal to 512. So what is our A? Our A is the first term. Our A is 2. R is 2 to the power n minus 1 times 2 to the power n minus 2 is equals to 512. Equals to 512. So therefore, you can see that all these ones, you are multiplying. You are multiplying numbers. So therefore, according to the rows of indices in Form 2, the rows of indices, if you are multiplying numbers with the same base, you put them under the same base, then add their powers. So this one, 2 times 2 to the power n minus 1, this is the same as saying 2 to the power 1, and this is 2 to the power 1. So therefore, you can take this as 2 to bracket 1 plus n minus 1. You are also multiplying, add the power 1 plus n minus 2. You put is equals to 512. Now, express 512 in the simplest form. In the simplest form of 2, 512. So 512 is the same as saying 2 to the power 9. 2 to the power 9. 2 to the power 9. Yeah, 2 to the power 9 is equal to 512. So therefore, instead of writing 512, you write 2 to the power 9. That's the concept of indices tested there. So therefore, you write 2 to the power 1 minus 1, that is 0. Then 1 minus 2, that's minus 1. So you get n plus n, 2n minus 1. is equals to 2 to power 9. Once we simplify this, the left hand side, we simplify this, we get 1 minus 1, that is 0. Then 1 minus 2, that's minus 1. Then n plus n is 2n. So you get on your left hand side, you have 2 to power 2n minus 1 is equals to 2 to power 9. 2 to power 9. And according to the rules of indices, if the base is the same, you are supposed to drop the base, equate the powers. You drop this base, equate the powers. You say 2n minus 1 is equals to 9. So 2n minus 1 equals 9. So therefore, take this 1 on this side. You add 1. This is minus on this side. When you take it on the other side, it becomes minus. So it becomes positive. So therefore, 2n is equals to 9 plus 1 is 10. So divide by 2, divide by 2. So our n is equals to 5. Our n is equals to 5. So therefore, this kind of a GP question, that's how you find the value of n. The value of n. So our n is 5. So you can see, you must understand the concept of finding the nth term. Nth term. That's a formula. Plus, you understand the rules of indices on multiplication. That is in form 2. So therefore, you can see the kind of question that was tested there. So thank you very much for this lesson. So thank you very much.